So our first step, it says to find the perimeter of ABD. So that would be this triangle here. So what do we do? Add all the sides. Yeah, we count. So how far is this side?
5.
This side's 5. How far is this side?
6.
This side's 6. So we have 5 plus 6. What do I have to do for this side? Pythagorean theorem. So I'm going to do my 5 squared plus 6 squared equals c squared. That comes out, to save us some time in our notes, I'm just going to tell you that comes out to 7.8 when we do it. And we're going to actually, since it asks us to find the perimeter, we're going to get the actual decimal answer here. And so then I do 5 plus 6 plus 7.8 gives me 18.8. It doesn't give me units here, so I'm not going to put inches squared or anything. Alright, B, C, and D. Do we already have one of those sides counted?
Yes.
Yeah, which one's that? Yeah. So B, C, D, well, we have the 6th side counted, but we haven't actually found either of these sides yet, have we? So here we can either plug the points values in, or we can count, how far is this up here? 4. So I can do 4 and 3, and then this side's also 4 and 3, right? To find out what these... So are these sides going to be equal?
Yes.
Yeah. And so I just do 4 squared plus 3 squared equals c squared, which comes out to, 25 equals c squared, so 5 equals c. And because these ones happen to come out exactly the same, I'm going to count that for both of them. So 6 plus 5 plus 5 equals 16. All right. So now we're going to find the perimeter of the whole quadrilateral. So A, B, C, D. So just the outside ones. So what does AB measure? We already have found it. So let's just 5. Yeah, we can't add those straight because those both include this line in the middle, which isn't going to be in it. So this is 5. How about BC? That we already found. 5. CD is also 5. And then what is DA? So 7.8. And when we add them all together, 22.8. Alright, how do we find the area of a triangle is what comes next. Multiply base times height divided by 2. So area of a triangle, if you want to write that down. And so remember, base and height always have to be perpendicular. So for ABD, is that already perpendicular sides up here? Yes, and how do we know? Because we're in a coordinate plane and they're level, right? And so they're already perpendicular sides, and so we just do 5 times 6 divided by 2, which gives us 15. This one I'm going to go ahead and put units squared here because it's important to know now we're doing area, and so we're dealing with squared units, not just straight counting. Sorry, some of you guys couldn't see that. All right, BCD. What is my base of BCD? 6. What's my height of BCD?
4.
Yeah, 4. So just remember that base and height have to be perpendicular, so we have to take this middle one that's perpendicular. What did you say?
No, they just keep coming and just going out.
I think it's just part of the security check they have to do. So 6 times 4 divided by 2, what's that come out to?
12.
12. And again, we're going to put units squared there. And then to find the area of the whole quadrilateral, what are we going to do?
Combine.
Yeah, we just...
The base and the height.
So quadrilateral, if it's a square or a parallelogram, it's just base times height. If it's this, though, what would I consider the base of this figure? Yeah, that's kind of the problem. Like 5 is the base of this, 6 is the base of this. What would I consider the height of the whole figure? As kind of hard. So if it's not like a parallelogram or something, I just have to divide it into the parts. So this one is easy to just take the two triangles we already have and add them together, right? If you have like a parallelogram, if I had something like this, let's just pretend that I did this. Well, I could find, if I can find base and height that are perpendicular, you can multiply those for a parallelogram. I'll see if I can find you a better picture later. But if you can't find easy base and height, just divide it into triangles and find the areas from there. Okay, so that's what you do on quadrilaterals. And so since we've already found them, that's really easy for us to do. 15 plus 12. 27 units squared. Okay, so on here, this whole thing is talking about just estimating. If we have a rounded shaded area here, which is like our sine curve or part of the cosine curve down here, we're saying how can we estimate what the approximate area would be. So do you have, anyone have any idea how we can figure out what approximately what one of those squares would be? Okay, so the easiest way to figure out one square is I'm going to come ahead to this side is 0 to 1, so the 1 is all the way up here. So I'm going to draw a square out here, and then this side is pi. So I'm going to start by finding the area of the whole big rectangle that I just drew. Okay, so that would be 1 times pi, which equals approximately, do you guys remember what pi is? 3.14. Okay, and then we're going to count how many squares are in that area that I just drew. So let's find so how many squares are up this side? 5 up this side. How many are across the top? 10. And so that's about 50 squares. So I just found the area of the whole thing is 3.14. So what is one square going to be if there's 50 squares there? Do I multiply or divide or add or subtract? Divide. Okay, so I have the whole thing is 3.14. I have to divide it by 50 to find out what one square is. And I most definitely need a calculator, which I don't have. Can someone type that in for me? .28. I have. My answer key is 0.0628.
Yeah, that's right.
Okay.
Yeah, I got 0.062.
Okay, so close enough. Alright, now we're going to count, and it says approximately, so it doesn't have to be exact. Approximately how many squares make up the shaded region? So go ahead and take just a minute to count. Let's see how, we'll probably get a little variation, but approximately how many squares make up the shaded region? So if you have half of one, count it as, find 2 halves to equal a whole. What did you get? 32. Yeah, 32. Okay. Did anyone get 31? You got 31. So hopefully everyone got somewhere around 31 to 32. Alright, so I'll write this down. Okay, so now if I know each square is this, and I have, let's go with the 32 squares. Okay, it could be either, and I have 32 squares, what am I going to do with those to find the area of the curve? Multiply, so 32 times 0.0628. Someone with a calculator. So it's 2.00696. And so we're going to just round that to about 2 units squared. Do you guys know that the wavy lines mean approximately? So 2 units squared. Alright, we're going to take about 1 minute, and Landon, can you set the timer for us? See how far you can get in solving number 2 on your own. So following the same 3 steps. You figure out what 1 square unit was. Anyone?
Wait, what is?
What was it? 0.125. Okay, so let's do the math. So again, we're going to figure out how many squares is there when we draw a square. I have 5 by 5, right? And so this time it's pi over 2, right?
Yes.
So 1 times pi over 2. So pi over 2 is 1.57 divided by the 25 squares. Comes out to 0.0628. Did everyone else get about the same thing there? Okay. And then about how many squares are shaded?
25.
Okay, so 25 and a 15. So shaded?
Okay, 15.
Yeah, I would say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then 16 for the halves. I would say probably about 16. Yes?
I added my little baby half.
Where'd you get 1.57?
1.57 is pi divided by 2. Approximately pi divided by 2. Okay, so then we just do this times the 16 squares. Okay, remember we're recording, so if you're talking, your voice is probably on the recording. Okay, and so then it comes out to about, what is that when you multiply it? 16 point something. You just got 16. So approximately 16 square units. Yes or no?
Hang on, let me.
What is it? For the total answer? Okay. Okay, I think you're right. I think so. We have approximately 16 units, and then 1.0048 would be our units squared. Okay, so that's probably going to be your challenge part of your assignment for today. What we're going to do now